Okay, so today we're going to learn about how to do two sample tests. So first, I'm going to present you guys with the problem. The problem states, patients experience symptoms of a heart attack and are routinely transported to a hospital in an ambulance. In a study of a new treatment thought to reduce the damage to the heart, patients are experiencing symptoms of a heart attack were randomly selected from one of two groups. During the transportation to the hospital, patients in one group received standard care and patients in the other group received new treatment, consisting of standard care and application of blood pressure cuff. The response value measured for each patient was a number between 1 and 0, referring to the cardiac salvage index MSI. A higher MSI indicates a more positive outcome for the patient. Summary statistics for the MSI response of the two groups are shown in the table below. So here's the table and here are the summary statistics for the MSI. And we're asked to see if the data provides convincing statistical evidence that new treatment results in a higher mean MSI value than the standard treatment. Okay, so what should we do? The first step anytime we get a problem is provide the null hypothesis and the alternative hypothesis. In this case, the null hypothesis when having a two-sample test is always H of the population is going to be equal to 0, meaning that there's no difference. Here, the alternative hypothesis, what the problem is suggesting, is that actually the new treatment results in higher MSIs. Therefore, that H1, or that if we take the new treatment as the mean as the U1, therefore that U1 is more than U2, right? So after listing our null hypothesis and our alternative hypothesis, which are here, we check our conditions. The conditions are: is it a random sample, is it normal, and if there's independence. We can see that yes, it is a random sample because it was stated. We know that there's normality because the population of the samples is greater than 30, as you can see here, 56 and 56. And it's reasonable to assume independence, as I don't think the heart attack of one person will affect others, right? So now we have to state an approach. So sigma is not given. We have three approaches we can take. We can take a two-sample t-test, a two-sample z-test, and a two-sample z-proportion test. In this case, it's not proportion, so it can't be the proportion test, and sigma is not given. Therefore, our approach is going to be the two-sample t-test, right? So now, what do we do when we know it's a two-sample t-test? Well, we go to a calculator, press on, and then we go to stat test, and we look for the two-sample t-test, which in this case is here. Now we put all our data. Going back to our data here, we know that the new treatment mean is 0.69, the standard deviation is 0.27, and the number of participants is 56. Now the mean for the standard treatment is 0.57, standard deviation 0.26, and then the number of participants is also 56. As we stated, our alternative hypothesis is that the mu1 for the first sample of the new treatment is bigger than that of mu2. And remember, we never pull. It's always right not to pull. So now we go to calculate, and we see that our p-value here, 0.0069, is really, really small. See? It's really, really small. It's really, really small. Now, since it's really, really small, we go to our last step. Our last step is making a conclusion sentence. Our conclusion sentence in this case is saying, because p is 0.009, which is really, really small, we have strong evidence to suggest that the new treatment is more prone to give a higher mean value MSI than the standard care. So that is basically what you have to do when getting a problem that involves two-sample tests. In this case, this was a problem presented, and I hope you guys liked the explanation and the steps to getting the right answer.